Hello to everyone. I am Professor Raja, working as Assistant Professor, EC Department, SNS College of Technology, and Autonomous Institution, Coimbatore. In this YouTube video, I am going to discuss about 23 ECET 221 microprocessors and microcontroller subject under Unit 5 microcontroller applications and advanced processor for the topic elevator system. As you know very well, microcontroller is a pure electronic device which is capable to perform an arithmetic and logical operation which is very important in the era of 1980. After this microcontroller has developed a lot, and this can develop a more number of applications with a large number of mathematical calculations. This application of microcontroller can be expanded in a real time. These microcontrollers are used in automatic washing machine, automatic chocolate vending machine, automatic vehicle controller, then automatic chapati making machine, and automatic any vectors which is working in the form of electronics. Now I am going to discuss about how these microcontrollers are implemented in the elevator system. This right hand side figure shows how the elevator system is look like, and this left hand side figure shows how the elevator control system inside blocks are look like. So this figure shows the how the microcontroller is working. Now it design a DT empathy part. In this stage we observe how people interact with elevators in real environments. So if you see this part, the persons are going inside, and this is the output path where how the elevator is working. Users expect elevators to arrive quickly and operate smoothly. Elderly people and disabled users need simple controls and safety features. Building owners want systems that are reliable and energy efficient. Maintenance teams require systems that are easy to monitor and repair. So these are the components of elevator control system. First one is the very important topic is microcontroller, that is the brain of the system, processes inputs and controls elevator operation. Second one is the sensors. Sensor detect position, weight of the cab, and open and close of the doors. Next, the output display system. LCD panel shows the current floor number and the direction which we want to move from one place to another place. Next one is the motor and motor driver. So this is the motor and motor driver. It will drive the elevator motor to move the cabin up and down. Next is the control panel, where we have used the user panel which buttons for floor selection and emergency call. Then power supply and backup. It ensures stable power supply and backup during outages, and power supply and backup. So these power supply and packages are very useful to provide a proper power supply from the elevator to move from one stage to the another stage. Next, if any emergency case is there, suppose if the lift is not properly working, or if any fire conditions are occurred, then that time the emergency systems are used. The various emergency system used in this elevator control system are alarm button, speakers, lights for emergency situations. Next, sensor interfacing. After understanding users, the main problem in elevator systems are identified. One common issue is long waiting times during busy hours. Another challenge is ensuring safety during power failure or technical errors. The system must also handle multiple requests from different floors efficiently. Therefore, the problem is designing a smart, reliable elevator control system. So this is how the elevator is look like. So from the input, so input and user interfaces are classified as landing call buttons, car operating panels, door sensors, car position sensors, and load sensors. Second, the main elevator system. In this main elevator system, the central processor is there, scheduling and dispatch logic is there, fault tolerance and diagnosis is there. So the input is derived by this microcontroller. Then the microcontroller also gets some input from building management system interface, traffic data, fire alarm system, and security integration for security purpose. And some of the output which we need to derive are output drives and actuators, which is given to a variable voltage, variable frequency motor drive, elevator traction motor, brake control unit, door operator motor, and a car display and voice announcement. Sometimes if you reach the third floor, you are reached the third floor like that, these messages are displayed. And some key identifying problems are traffic prediction algorithm, zoning strategies, dynamic floor assignment, and if you want to provide a safety controller means emergency power management system, fault tolerant CAN bus, independent safety relay circuit, and condition monitoring. So if you are a student, you have to identify what are the inputs which is need to give to the elevator, and what are all the output which are derived from this elevator, and if any problem is there, if any emergency case is there, how can you solve that? That is very very important. So this is the normal block diagram of elevator control system. As I told earlier, input power supply, charging circuit, storage battery are for the input to this emergency elevator system. Then the elevator control system motor is connected to this. Then the output is elevator door open and close, brake control, and a track monitoring system. So the electronic components which is used in elevator control system are the microcontroller or PLC act as the brain of the elevator system. Motor drivers control the movement and the speed of the elevator motor. Sensors detect position, door status, and passengers weight. Control panel allow user to select floors and operate the elevator. Power supply system provides stable electricity for safe operation. Next, this is the model diagram. If you are a computer science student, then this model diagram is very very important. When a user presses a floor button, the signal is sent to the controller. The controller processes the request and decides the elevator's movements. The motor system moves the elevator up and down accordingly. Sensors continuously monitor position and safety condition. The elevator stops accurately at the selected floor. So this is a prototype model where you have to use all these. So this is the microcontroller. These are the input button. These are the output elevators, and sometimes the emergency circuit will there, and this is the motor control is there. A prototype elevator control system can be built using a microcontrollers like Arduino. Sensors can be used to detect floors and door positions. A motor drive module controls the elevator motor. Displays can show the current floor and the system bus. Emergency buttons and alarms can be included for safety. Next is the application of elevator. These elevators can be used in office buildings, residential apartments, shopping malls, and finally these are mainly used in hospitals. So this is the mind map where you have to study how these all topics are classified, and these are the reference paper which I have taken for this topic. Finally, so in this YouTube video I discussed how the elevator control system is working, and what are these construction are carried out, and how the block diagrams are constructed, and what are the various application areas that the elevators are using. So thank you for watching my video. Next YouTube video I will bring with the new innovative topic for discussion. Thank you.